I'm Sean Sullivan, here to talk about dependency management. I'm a platform engineer at Grubhub. Um, Grubhub's a food delivery business, but we got acquired this year. We're part of a bigger business called the Wonder Group, which is kind of like a restaurant business on the East Coast. Um, so as a platform engineer, I work on Java every day. Last time I used Java was about an hour ago. And in fact, I spent most of today fixing dependency management problems in some applications. That's as a platform engineer, that's almost a daily activity. Um, let's see if I can make this work. Yeah, I live here in Portland. I've been using Java forever. Been involved here at the Java user group since the dawn of time. I try to stay active with open source. Recently, been contributing to the Open Rewrite project. I've contributed a bunch of recipes, some for Netty, test containers, and Jackson. So lots of goodies there. Um, so we'll talk about dependency management. Let me see if I can get. Um, So I've been practicing generating images with Google Gemini. And I told it to create a representation of a day in the life that I have. And this is what it came up with. Um, but I think this is pretty common for Java developers. You're working on a project, everything's going well, and then all of a sudden you've got some sort of dependency issue, and then you got to work through it. So you get tangled up, and then you got to untangle everything that's happening. See if I can get this. Trying to hide the. Hold on here.
Oh, you should be dragging.
Yeah, I thought I could hide the control. I don't know if that's showing up on the recording, but anyway, let's back up here. All right, so where I work, we've got a microservice architecture. Pretty much everything runs on the JVM. And so we've got these fairly large microservices, which may have started small, but over time they grow larger and larger. And so you start off with maybe 10 libraries on your class path, that grows to 50, and then suddenly you've got like hundreds of things on your class path. So the kinds of things we have in production, it's a combination of some internal libraries that we built and use internally, and then open source projects that we put into the application. So like we use Spring Boot, we use the Jackson library, things like that. And of course, we've got all the flavors of JVM languages, Java, Kotlin, and Scala. And it's not uncommon for big companies with big projects to have all flavors of these running in production. I mean, they're all jar files in the end, but ultimately it's part of our stack. So here's the question. How many of you have outdated libraries on your production class path? I mean, everybody, right? Like nobody runs on the bleeding edge of libraries. Um, and usually that's fine. Like not really a big deal until one day you wake up and you come into work and like there's some like CVE has been announced, there's a security incident, and somebody's like pinging you on Slack and they're like, hey, we got to fix this CVE, go upgrade your libraries and go release everything and redeploy. But what's the worst case scenario? Well, a couple of years ago, I guess this was 2017, Equifax had a really bad day, and all their customers, probably all of us in the room, probably have credit reports on Equifax. Equifax knows about everybody in the world, I guess, but there was this cyber attack and a bunch of data got taken. Um, and so it was a bad day for customers of Equifax, bad day for the software team at Equifax. But along the way, there was a significant penalty. So, like, this is an example of like something that can go sideways, where like your application is vulnerable, there's a cyber attack, and then your company ends up being penalized for it. And believe it or not, there was actually a congressional hearing about Equifax, and the CEO had to answer questions. And you might recognize Greg Walden. He actually was a U.S. representative representing districts in Oregon. And so he was on this committee, and he's like grilling the Equifax CEO. And what's hilarious about this is he starts asking very specific questions about like what happened, and so he this is a direct quote from this committee hearing, and he says to the Equifax CEO, he's like, "Oh yeah, well you guys were running Apache Struts as your web framework, and it had a known vulnerability, so like why didn't you patch it and roll it out to production?" And so 2000. I mean, that's a very specific thing to say at a political committee, but so hopefully that won't be you. You never want to be the person having to answer that question about a software vulnerability, about jar files, basically. To my knowledge, that's the only time jar files were discussed in Washington, D.C. But so if you're like me, you like to do greenfield projects because you're just starting from scratch. Maybe you pick the latest version of Spring. Hopefully, there's no vulnerabilities and life is good. Um, and that's your best case scenario, greenfield development, right? But over time, your little greenfield project starts to get bigger and bigger. You have more and more dependencies, and then you run into a scenario where you've incorporated a bunch of internal libraries, a bunch of open source libraries, and maybe they conflict with each other. Maybe you've got like an internal library that's running like Jackson 2.16, and then you're using some open source library that wants Jackson 2.20. And it sounds like that should be fine, but inevitably something goes sideways. So as a developer, everything's great until like your bicycle hits the train tracks, and then suddenly you gotta go fix the problem. Um, So back in 2019, the Gradle Incorporated has a blog, and it's a really interesting blog post because it says basically that every software developer encounters these kinds of problems. Your application grows bigger and bigger, your dependency graph gets increasingly complex, and then the code is just harder to maintain. Um, And to quote the article, dependency issues can cause many problems. Um, and if you're extremely lucky, the Java compiler will tell you there's a problem. So you'll try to change the Jackson library to the latest. You recompile your code. Maybe you run a Jenkins build, and the compiler will fail, and it'll tell you specifically like, oh, this import's wrong or something else. And that's like a good problem to have because the compiler is type checking everything. It's sort of like helping to steer you in the right direction. Um, but compilers are not the only thing that goes wrong with your dependencies. You can also have these like runtime errors. And this is where things get really ugly as a developer, where like maybe all the code compiled, all your unit tests passed, maybe your integration test passed, and then you deploy out to EC2 or something, and then suddenly like it blows up. Um, and that happens a lot, to be frank. But so these are like runtime failures of your application. And so that usually means there's some sort of Java throwable that's happening at runtime. You may have a class def found error, no class def found error, or a class not found exception. These are like common things that go on. Um, you may also see things like a no such method error. And that means that like, oh, like the compiler thought all the methods were there, but then at runtime, there's some other library conflict where like maybe a different class got loaded at runtime in production or something, and then like the method's not there. And then there's other things like an unsatisfied link error. This has to do with like if you have a Java library that uses JNI to load native libraries, something like Netty. Netty loads native code. Maybe there's something weird going on with some native code, and so the Java runtime could tell you that, hey, I can't load the native code. So how do we get into this problem? Well, ultimately, like your build tool is doing some sort of dependency resolution, right? Um, and so you're declaring your dependencies in some sort of project build. And then when you're executing your build tool, it's trying to reconcile the dependencies that you've declared. So here's an example of what maybe you might do with Gradle. Let's say this is my application at work, and I'm depending on two internal libraries called Library A, Library Z, and then I'm also using Guava because Guava is incredibly prevalent in Java systems. So this looks really simple. Like, what could go wrong here? Well, it really comes down to what does the dependency graph look like? So your build tool is going to look at those dependencies, and it's going to analyze the things that you've declared, and then it's going to look at all the transitive dependencies that it needs to add into your project. So in this case, like library A has a transitive dependency. It brings in Guava 33. And my application had a dependency declaration that said I need Guava 28. And then maybe library Z wants a different version of Guava 19. So it started off as a simple set of dependencies, now looks incredibly different. And as you see here, the dependency graph is now saying, oh, we've detected maybe 3 different versions of Guava. So that's interesting. And what happens is your build tool has to make a decision about how it's going to select one of those 3 versions of Guava. And it turns out that Gradle and Maven do different things. So this is a subtle fact of life for Java developers, but Gradle's default policy is called highest version wins. So Guava 33 would be selected out of that dependency graph. And the Maven ecosystem has a different set of logic. It's called nearest wins. And that just means that nearest to like the root of the graph, let's say. And because in my build file, maybe I've explicitly declared Guava 28 in my Maven POM XML. That's considered the nearest because I explicitly declared it. And then it's going to ignore any other version of Guava that's in the transitive network.
You don't actually need those exclusion lines with Gradle or Maven.
You do.
You still
You
do?
do.
Yeah, okay.
In the end, that is a common strategy to try to like overcome these difficulties. Is like if you know that some version of Guava is problematic, you might explicitly try to exclude it. So if you're in the Maven world, just know that it's resolving your dependency graph in a totally different way from like a Gradle build. And this was surprising to me. Like I actually have been doing Java for a long time, and then no one had ever like pointed this out to me. I just sort of didn't know it. But a few years ago, I had an interview with a tech company in Silicon Valley, and one of the interview questions was this. They asked me to explain the difference between how dependencies were resolved between these tools. And and I correctly explained the Gradle behavior, but I could not articulate the Maven behavior. And anyway, the interviewer said it's called nearest wins. Like the interviewer gave me the answer, and I didn't really know that. And then a few weeks later, they gave me a coding exercise and they asked me to implement nearest wins. They said, imagine you're implementing Maven and you need to traverse the graph and then figure out what all the dependencies are and then pick the nearest. Um, and then
So what would you have done if there were, like in your graph before, where you had, if there was no 28.2 and you only had to go through lib A and lib C? You had
it's the first declaration that takes precedence.
It's the first in the list.
Okay.
It's not.
You guys have already solved it.
It's
Okay.
yeah, it's
Thought I could trick you.
Maybe not solve that.
Okay.
yeah, the Maven's public documentation like explicitly says that, but nobody reads the docs, and I certainly didn't know that until like recently.
Okay.
But anyway, if you're ever interviewing with a company in Silicon Valley, I'm not going to reveal who they were, but they seem to care a lot about this. And I did not get the answer right. And I'm not working for that company. Anyway, so there's this so when I was putting these slides together, I sent an early draft of this to one of my friends in Texas, and he's like, Sean, do you know about this blog post from Jake Wharton? And I was like, no, what? Tell me. And he goes, yeah, you need to read this. So this was Jake Wharton, I think worked at Square. I don't know if he's still there, but he maintains a bunch of Kotlin libraries. So like OK HTTP is one of them. And he's got some great blog posts about the Java ecosystem, but this might be his best blog post. He's basically, he says he doesn't like Maven's dependency resolution. And he kind of makes the case that like Gradle is the right way, and it's caused headaches for him as he's trying to support some of the open source libraries that he's put out to the world. So sometimes people will like file bugs against his library and they'll be like, yeah, your Kotlin library is broken. And he'll say, no, you're using Maven and it's resolving nearest wins, and that's the problem. And so it's actually been sort of a headache, and it can be for obvious reasons. Like if you're new to Maven, like you might not know this, and in fact, it's just incredibly subtle behavior. So anyway, and then further in the article, he calls Maven as objectively bonkers. And so about in September, I was at a conference in Minneapolis. It was basically the Apache developer conference. And I was giving this talk in a room of Apache people. And there was a guy in the room who raised his hand and he said, oh, I work on Apache Maven. And he was explaining to me like sort of like the philosophy of Maven. So it was like really, really helpful to like hear that level of detail. But it's sort of controversial. People that are in the Gradle camp, they're like, yeah, Gradle's the right answer. Gradle's perfect. And then people in the Maven camp are like, Gradle's crazy. Maven's the right way. So yeah, whatever. Pick your favorite tool and stick with it and just learn how it works. Anyway, so inherently all these jar files that you have, they're all on a class path, and that's where things get ugly. And where I work, I'm on a platform team, and we ask ourselves questions like, what libraries do we have in production right now? Because we need to sort of like phase out old libraries, but we need to have an inventory of like what's running in prod. And some companies don't know this. Like they don't have a way to like quickly look this up. And where where I work, we actually have like a little web app that we built internally that lets me like drill in and I can go look at like different libraries that are running in prod. So if like there was a CVE that came out tomorrow morning, I would know exactly that I could go look and see like, oh yeah, that's a problem for us or not. And you want to know, are your libraries outdated or not? So if you're running like Apache struts or something, and it's outdated by like 5 years, you might want to know about that. But you know, this is important. Like even if a couple of years ago there was the Log4j incident, um, where lots of companies were impacted and lots of companies had to redeploy with new versions of Log4j. And so you'd want to know if you were running an outdated version of Log4j, for example, if you know, hopefully you have a way to query your production environment and see what versions of Log4j are out in your environment. And then you want to know like, oh, do I have any snapshot version libraries in prod? And at my job, I just assumed we didn't have any until one day, Tuesday morning, I went into work and like half of our Jenkins builds were failing across the whole company. And we have like a Slack channel for people to post questions about build failures. And yeah, like half the builds were just host. And it turned out it was because there was had a dependency on a snapshot. And this is sort of what that's what I looked like that morning. But we had microservices that were like Spring Boot and Juice and Jersey and things. And then the applications were using an internal shared library. And that library had last been published like 2 years ago or something. But 2 years ago, when it got published to Artifactory, it was somehow had a dependency on Swagger Annotations 2231 snapshot. I didn't even know that was in our production environment. But one day, so for 2 years, everything was good. All our Jenkins builds were super good. And then on a Tuesday morning, suddenly that snapshot no longer existed anywhere on the internet. It expired, I guess. But you really should never depend on a snapshot for like your production apps. But we ended up having to re-release our shared library on a more recent version of Swagger. And then we had to re-release a bunch of things and we had to rebuild and we sort of made everything work, but it was a fire drill that we weren't expecting. So watch out for that. Now, as a developer, whenever I go to a conference, I'm always hearing about these great new libraries out in the world. And when I'm at a conference, I'm like, ooh, that looks like the perfect library to put on my next project, or maybe I'll just dump it into an existing project. And I'm literally a cowboy. I'll go like try new things all the time. And it seems like harmless. Like you probably have experienced this yourself, where like you're like, ah man, here's this crazy new thing. I want to, maybe it's an AI library, right? And you're like, I'll just put in my build file and what could go wrong? And inevitably it brings in a transitive dependency graph of its own. And then your application dependencies and the transitive dependencies of the new library just sort of conflict with each other. Maybe they have different versions of Lava, for example. But so as your application is growing with more and more libraries, you're just accumulating more jars on your class path, and everything's fine until one day it's not fine. And so I like to say that, yeah, I'm the little dog where everything's on fire. I just don't know about it. And I'm just drinking my coffee at work in the morning. And then one day someone's like, tells me that like the whole building's on fire. And that happens a lot. We call this dependency hell. You've got all these jars. The jars are not cooperating with each other. They're conflicting. And this is common, like literally every company I've worked for in the last 20 years, like we've encountered dependency hell. I think my first job out of college, it was actually Windows 95 had DLL hell Anyone remember DLL hell? But this is just jar hell, basically. And there's in fact a Wikipedia article called jar hell. If you type in jar hell, and they explain it's just a subclassification of dependency hell. But every company I work for has this issue, and you kind of have to be proactive to like fix these problems. So 10 years ago, I was at an e-commerce company called Gilt.com. And we had all kinds of dependency hell at Gilt. We were doing microservices. All our microservices used a shared common library that we called Gilt Commons. And by the way, most companies have a commons library or a library with a different name like core. So I work for companies that have core libraries and common libraries. At Grubhub, all of our libraries are named after food. Everything is a food theme. So we have things, we have common libraries, but food related. Anyway, so when I was at Gilt, we were actually using Scala as well, and we were having to cross compile everything into 2 or 3 versions of Scala. It was like Scala 2.9, Scala 2.10, Scala 2.11. And then we were also using Guava as an internal dependency within our commons. And this caused all kinds of problems because we had other teams that wanted to use other versions of Guava, but they couldn't upgrade because our commons was stuck on the old version of Guava. And then gradually we had to like move forward. But anyway, there's a recording of this. It was a QCon talk in 2015, explaining like how bad, how like your company's productivity gets slowed down because everyone's like dealing with dependency hell. So that was a big problem at Gilt. And then Netflix has had its own problems with dependency hell. There's a talk on the internet on YouTube from Mike McGarr, and he talked about Netflix has sort of well, it used to be called a distributed monolith, where like there's all these microservices all written in Java, but they all were sharing the same common libraries. And then so they had sort of a binary coupling problem. Everybody wanted to share the same libraries, but then it was hard to evolve the libraries forward. And so there's a talk on YouTube about that. Anyway, so Gradle itself can sort of cause issues for you if you're not careful. Gradle, wants to do this dependency resolution to pick the latest version of Guava for you. But that might actually cause problems because Guava itself is not fully backwards compatible. There's like the Google is like very clear. Like they tell you that like new releases, new major versions of Guava are not necessarily backwards compatible with old versions of Guava. So if you're trying to leap from like Guava 19 to Guava 33, turns out like there's not a lot of backwards compatibility there. And so anyway, you can run into issues where like, oh, Gradle's trying to be helpful and it's trying to move you onto Guava 33, but that's really just going to screw things up potentially. So sometimes you want to tame dependency hell. And this is not easy, but some people use a technique of like forcing a dependency version. At Netflix, this was called pinning. They would just say, oh, pin it to the old version or pin it to the yesterday's version. Don't pick up the latest or something. And so in a Gradle build, you can have this force declaration, and you can say, okay, I'm going to override Gradle's default behavior. And I'm smart. I'm going to be smarter than Gradle. And I'm going to say, force this version because I don't want anything newer. And so occasionally I'll do this, but I really prefer not to, because this is just like you're manually intervening into the dependency resolution. And I only do this if I don't have any better answers for the problems I'm trying to solve. But at Netflix, this Mike McGar said that if you are forcing a specific version of a library with the force keyword, you're really just introducing technical debt into your Gradle build. And so you're going to have to undo that technical debt somewhere in the future. Maybe it's a week later, you'll undo the force. But this was a common thing, probably at every company I've worked for, where we've had to do a force to a specific version. But you only do it as a last resort. And whenever you've done it, file a ticket to go like clean it up later, like, because you might have to fix it down the road. Anyway, so how do you avoid like dependency hell? Where Google actually published a website called jlbp.dev. Has anyone been to jlbp.dev? So Google publishes a lot of, open source libraries, and Google Cloud team has a bunch of Java libraries. And they realized that they needed to follow some consistent practices for how Google releases Java code on the internet. And so they called it JLBP. And there's like 16 or 17 rules on this website, and they're all really good. But rule number one is you should minimize the number of dependencies in your application. Whenever you have the opportunity to subtract things out of your build file, that you should always try to do that. And maybe you want to remove Guava, because that tends to cause the most pain in the Java ecosystem. But generally, if you can shrink the size of your dependency graph, you're going to have fewer conflicts. It's not easy to do this, but sometimes you got to figure out a way to make it happen. And then you want to, as you're declaring dependencies in your build, you want to minimize dependency scope. I actually made a mistake in one of my projects a few years ago. I added JUnit to my build, and I forgot to declare it as a test scope. And somehow it ended up on my production runtime class path. Anyway, I always think of that example when I'm thinking about dependency scope. Like, you don't want to have your test libraries showing up on your production runtime. And then Google also says you should prefer JDK classes where available. So maybe there's the JDK has collections, right? JDK has a UUID. JDK has like a time, java.time. Try to favor those core classes rather than just grabbing some other libraries off the internet. 20 years ago, you needed all these extra libraries to do things, but the JDK has like built out sort of a better baseline now. And if you can build things just on JDK functionality, it's kind of better that way. And the other piece of advice from Google is for any given functionality, pick exactly one library. And I think a good example of this would be like JSON parsing. Like, there's probably a handful of JSON parsers out on the internet. Maybe some people like Jackson, maybe some people like Google JSON. But just pick one of them and stick with it. Don't like bring in 2 different Java parsers onto your project, because then you're just like inviting pain. And then you also want to separate your tool class path from your product class path. And this is good advice. I'll tell you how this applies at my job. One of the tools that we're using at work is Open Rewrite. And so we're using some Open Rewrite jars. Now, those Open Rewrite jars are really just tools that we use to do refactoring. They're not really part of our product, we don't need to deploy open rewrite jars onto a production EC2 instance to serve our customers. And so you need to think about which libraries are really just tools that you're using at maybe build time, and then which other things are like part of your application logic. And think about your class path separation really. So like where I work, we do not put open rewrite jars on our production runtime class path because they aren't needed. We don't refactor on demand. But we try not to. And then another tip from JLBP is keeping your dependencies up to date. Easier said than done. It's actually really hard to do that. Google says they aspire to upgrade the dependencies within 6 weeks. I wish I could do that at work, but it's actually incredibly hard. We have tons of old libraries running in production right now. It's very hard to just bump everything all at once and get the latest all the time. The only company I know that was like close to doing this was like sort of Netflix. For example, I used to work at Netflix a couple of years ago. I worked on the team that ran the API gateway. And the API gateway used Netty as the core building block for the gateway. And the Netty team does a monthly release. And when I was at Netflix, we would pretty much integrate the latest version of Netty the same week that it was released by the Netty folks. And we would frequently go to production with the latest version of Netty, like, yeah, within a week of getting it, we'd be able to, we were keeping pace with the monthly releases. We were always bumping Netty. I'd say we only really got burned on that significantly once, but I'm not going to share that story here. But nevertheless, like this is aspirational. Like it's aspirational. You should maybe think about how far have you drifted behind the latest version of Jackson, or how far are you behind the latest version of Guava? Things like that. And so JLPP also says staying up to date is important because sometimes there's a security fix. So maybe like Log4j has another security vulnerability that comes out unexpectedly on a Friday morning. How far are you behind on the Log4j train? And do you use Log4j? Do you use Logback? Like you should know these things so that you're ready to go patch when it's time to roll out. Google also says you should publish a bill of materials for your projects. So if you look at the Google Cloud SDK, Google Cloud SDK for Java always has a bill of materials available. And so that sort of helps with version management when you're publishing like a group of libraries. And the Netty project is the same way. Like Netty is sort of like a group of libraries. Netty has a bill of materials that gets published. And so that's incredibly helpful when open source authors do that. Google says you should ensure upper version alignment of dependencies for consumers. This is sort of like, yeah, try to pick the highest version of like a library. If you're publishing an open source library, try to depend on the latest version of things. I mean, there's pros and cons to that, but let's see. Yeah. So this is a direct quote from the website, but yeah, try to get the highest version is kind of what their philosophy is. Anyway, so we'll talk about more problems that emerge in big applications. I was working on an application a year ago, and I wanted to upgrade the Apache Iceberg library. And I did that and ran my build. And the build failed. And you know, the Java compiler like was unhappy and my Jenkins build was failing. And if you look really closely at the output of my build tool, it's like, oh, you want to use the new version of Iceberg, but you're on an older version of the JDK, and the latest Iceberg library, you know, requires like Java 17, but your build said that you're building for Java 11. And so the library has a minimum baseline of Java 17. And so if I want to use the latest version of Iceberg, I got to bump the minimum version of what my application's using. And this is incredibly common, and it's becoming more common because Oracle is releasing. There's the release train for the JDK that's more frequent now, and so you start to see these kinds of things happening more frequently out in the world. Another common problem, I see this happen at work all the time, is like dependency misalignment. We have a lot of legacy code in production, and crazy things happen with legacy code, but like if you're using Jackson, you want to make sure that all the Jackson libraries are kind of aligned on the same version. But even if they've drifted just a little bit, that can be a problem at runtime. So like typically you'll have Jackson core and Jackson data bind on your production class path. You want them to be at the same version number. You don't want any drift here. And I've seen this in lots of production code. It's like happens everywhere, unfortunately. Yeah, there's a Jackson bill of materials, and that's sort of the recommended way to consume Jackson. Yes. And then there's Scala is a whole other problem. Anyone used any Scala libraries? All right, I'll skip through this, but with Scala, there's like each version of Scala, you have to recompile your code for that version of Scala. So it's called cross build. SBT is the build tool, and in an SBT build, you define cross builds. And you say, I want my library to be compatible with Scala 2.11, Scala 2.12, 2.13, and Scala 3.0. Anyway, it turns out getting really ugly because they introduced this weird naming convention. See how it says Scala underscore 212 and Scala underscore 213? Well, if both of these things are on your class path, like you get these cryptic errors at runtime because the application doesn't know what version of Scala you're trying to use because you've basically brought in two libraries that are using incompatible versions of Scala. So Scala doesn't really provide good backwards compatibility, or it has a lot of nuance, and if you're not careful, things go sideways. And this actually happened to me at work like about 3 months ago. It was a Scala sad day for me. Anyway, so anyone here use Maven? Maven, okay. So Maven has a plugin called the Enforcer, and it's really a nice way to help manage your dependencies and enforce like cleanliness, I guess. If you look at like the Wildfly pom.xml, it explicitly uses banning certain dependencies from the project. But you can ban classes by class name. You can ban certain libraries by its artifact name. And then there's this thing called dependency convergence, and that's where like it'll look at your whole dependency graph and see like, oh, you have 3 versions of Guava, and it'll like flag that as an issue. And actually you can set up the enforcer to fail to build if you want to. And of course, in the Gradle ecosystem, someone ported the Maven enforcer to Gradle. It has similar feature parity. And Yeah, so like in a Gradle build, you would say something like, "Oh, I want to check for dependency convergence," and you can have a whole list of rules of other things that you care about for your build. So I've got a demo coming up, which I hope goes well, but the demo is going to include something about Open Rewrite. And oh, there's also an AI image about Open Rewrite that's coming up. Took me like an hour to get it right. So hopefully it's worth it. So Open Rewrite is like a refactoring tool. It allows you to refactor Java source code. And Open Rewrite can modify source files. It can also modify pom.xml. It can also modify a build.gradle file. So when you apply a recipe to a project, it can go like sweep through the whole source tree, can identify like, oh, there's a missing dependency. Like say you're upgrading from Spring Boot 2 to Spring Boot 3. A recipe that is trying to apply that upgrade to your source tree, it may need to add a new dependency or remove an old dependency or just rename dependencies, or maybe change the versions of certain things that are in your POM XML. And so this is a common thing that Open Rewrite provides to you. There's all these pre-written recipes that are out there, and it does all this magic under the hood. So we're going to talk about the Jackson library next in more detail. And there's actually some Open Rewrite recipes for Jackson. I actually started writing the recipes this summer, and then a couple other people like collaborated with me, and then we sort of figured out how to make Jackson 3 a thing that is now available through an Open Rewrite recipe. But so most of us here, we're probably all running Jackson 2 in production, right? Like some flavor of Jackson 2, because everybody has Jackson 2 on their class path. But this year, Jackson 3 just came out. I think it was like in the last 8 weeks. Jackson 3.0.0 became a generally available library. And so, you know, it's a major version bump. And it turns out that like Jackson 3 is a major, has major differences against Jackson 2. They renamed all the artifacts. So your group ID in Maven Central is actually different now. So in Jackson 2, it's called com.fasterxml.jackson. Well, in Jackson 3, they're like, oh, we're going to stop calling it fasterxml. So the new version of Jackson is called tools.jackson is the group ID. And then they renamed some other artifacts, and then they also repackaged all the code with the new package names. So in the old Jackson, the packages were com.fasterxml.jackson.core, whatever. The new release, all the Java package names are tools.jackson.core.whatever. Anyway, so the release notes for Jackson 3 explain to you how to do this.
There's a really good blog article on from the Spring team why they decided to have separate names for 2 and 3 so they can run both concurrently in packages.
Yeah, they coexist. The artifact names are different. That means that the jar files have different names, and that means you can have 2 versions of Jackson on your class path with unique file names. And then at runtime, you've got unique Java class package namespaces. So then you can have
reinforcing jar hell elements.
Yes.
Ignoring your whole spiel here.
Yes. So the individual who maintains Jackson is known as Cowtown Coder on the internet. And he put this blog post up last week. but he explains like why you might want to go to Jackson 3. And he makes a compelling case. And so like, yeah, like Spring Boot, the whole new Spring ecosystem will all use Jackson 3. So if you're looking at Spring Boot 4, they use Jackson 3 as sort of their baseline. I was gonna do like a cool demo. Hopefully I'll do this, but I spent like the whole afternoon creating these images. Um, I was hand drawing them with a pencil. But when I started this, I was gonna have these two in a boxing match because I thought, oh, these two approaches are like competitors and they're fighting each other. But it turns out you could actually use both of these together. You could, I'll show you a demo, but I figured they should be happy and smiley rather than just angry boxers. Um, so there's two techniques. I'll show you how to upgrade Jackson. And so one technique would be to just ask Copilot to do it for you. And I didn't think this was going to work. And I'm gonna go switch. I'm gonna switch over to see if I can make this legible. But so I have this little simple project, a GitHub, the Jackson Playground, and it doesn't really do very much. It's just like parses some JSON and whatever. But it's based on Jackson 2. So it has a pom.xml file, and in that there's the Jackson 2 BOM, basically. All right. So let's suppose let's see if I can find this. So this is relatively new in GitHub, but it's called the Agents panel. Anyone using this already? All right. So I'm just going to type in a task that I want an agent to perform. Okay. So I'm going to say upgrade Jackson library. Sorry. Version 2 to version 3. Okay. Now, hopefully that's unambiguous. Hopefully, like the agent tool can understand that, but we'll find out. So I'm going to say this is a task I want applied to this repo, and then I'm going to hit like the start task. Now, what's crazy about this is I don't have a paid subscription here on GitHub, and it's just going to go write some code for me for free. I presume there's some limits on this, but so it has actually kicked off an agent, and it's starting to perform some work in the background. So if I go to the agent dashboard here, it shows me that there's sort of an active task that's doing some work. And so when I click through here, I actually could watch Copilot as it's like going through all the steps that it wants to follow to solve this task. Now, while it's doing that, I'm just going to switch over and do the upgrade with Open Rewrite. Why not? And I've already, let me make this bigger. Yeah, I guess it's a boxing match, but so I already put like a little shell script here. What's it called there? Jackson 2 to 3 shell script. So this I already read this, but this is a shell script that will invoke the Open Rewrite plugin, and it will load the recipe that I want to use. And it'll apply it to my source tree. So here I'm running this. And it's done. So in 4.9 seconds, it just made changes to my local copy of this repo. And now we're going to go look at what it changed. So in my local file system, the Open Rewrite recipe changed my POM XML. And it also changed the source code where I was importing some Jackson classes. So what this recipe does is it detected that I was using the Jackson BOM 2.20, and it replaced it with the latest version of Jackson, which is 3.01. And you can see it changed the group ID as it should have. That's correct. And then what else did it do? It replaced all the group IDs in this XML file as it should, more or less. But what else happened here? Oh, it's removing, actually, if you look closely here, it removes Jackson module parameter names and Jackson data type JSR 310 and Jackson data type JDK 8. It removed these 3 entries because they don't apply in Jackson 3. Jackson 3 sort of folded that functionality into Jackson 3 core. So Jackson 3 core, there's no reason to pull in these libraries. They don't exist in the 3.x release train. So the open rewrite recipe knows that these need to be deleted. So it does that. And then let's see if I can find anything else that's in here. Yeah. So I'm going to go click on the source file. There's some Java source code in this project. And the open rewrite recipe did the cleanup that it was supposed to do. It changed the imports. I got rid of the faster XML, I replaced it with tools.jackson. And it also replaced one of the exception classes because in Jackson 2 uses checked exceptions. Jackson 3 does not have checked exceptions, and so they actually changed some of the class names and whatnot. But this is sort of a normal thing where you don't want to use Jackson processing exception necessarily when you're migrating. Anyway, so this is the code, and yeah, it's a little Java source file. But Open Rewrite did this in 5 seconds. Now let's go switch back to my agent and see if my agent is still working. I don't know if it's still working, but let's scroll through here.
Timer's still going up top.
Yeah. Looks like it says Copilot is still working. All right, so it's like figuring it out, or somehow it's already been trained on how to do this. But go back here. Let me go back and back. Okay, so I'm gonna go click on pull requests. And what the agent has done is it's got a draft pull request already open here. And this draft pull request actually is incomplete because it says files change 0. So that task is still running in the background, and we're waiting for it to finish its work, and then it's going to push everything onto this PR. But what's fascinating is that like it came up with a plan. This is what it's executing under the covers, and it tells you what it's doing. It's like, hey, the BOM needs updating, and then the group ID needs to change, and the package imports should be changed. And then it's smart. It also says we're going to run the tests and make sure the tests pass, and then fix any compilation errors. And that's actually nice that Copilot will fix compilation errors for you. There's another tool that I've been using at work. It's not Copilot, and I'm not going to name it here, but it will frequently change my source tree and the results do not compile. And I have to keep telling it, like, go fix the compilers. And you don't want to have an agent that's just creating like messes of code that doesn't compile. But so let's see. I'm surprised that this hasn't finished yet, but
So you cannot say which one it is?
I
Are the initials C and C, maybe?
no, I'm not gonna, I'm not gonna name it. But so Copilot, what's interesting here is I was able to invoke the recipe on the command line and had results instantaneously, whereas this is like the AI tool is like figuring out how to do it. So, you know, I already knew how to do it, so I just wrote a shell script that I could invoke. But so typically, if you're using Open Rewrite, there is like a web GUI to it. There's a commercial version of Open Rewrite from a company called Modern. Modern sells like sort of an enterprise solution. It's a web application you deploy internally, and then you can apply recipes through a web GUI. And that's what we're doing at Grubhub. We have the Modern platform to run recipes. We don't do command line invocation.
Something like this, is the recipe very specific about what version you have to have, or is like the major version close enough? Or what do you want it for something like upgrading?
That's a good question. I forget how it was written.
It usually uses the latest version that it finds in there.
Yeah.
Like
You
maybe.
you can use version selectors, and the recipe say, if you see this version, $2, go ahead and.
Okay.
Yeah, let me bring it up here. So the library, or sorry, the recipe that will migrate Jackson 2 to Jackson 3 is actually a YAML file. And this YAML file is what the Open Rewrite tool is executing. Well, Open Rewrite reads this YAML file and then figures out all the steps that need to happen. And so it's what it's doing is it's executing a recipe list. And the first recipe in the recipe list is changing the dependencies. And then after that, it goes and changes all the types and then rename methods and things. But yeah, I forget. It's been a while since I looked at this, but there is a subtle thing here. If you look at center here, but see where it says that Jackson Annotations has a version of 2.20? Well, it turns out Jackson 3 uses Jackson Annotations 2.20. So this is the only artifact that did not get a rename. And the reason they were afraid of breaking people's production apps. If you had republished new annotations that had different Java package names, then like things could go sideways. Yeah. So Jackson 2 and Jackson 3 share the same annotations. And so last Friday at work, I was using a different AI tool, and I asked an AI tool to go do a Jackson 3 upgrade. And I didn't tell it much more than that. And it told me that everything in Jackson 3 was com.fasterxml.jackson.v3. And then it tried applying that to my source tree. And it was just hallucinating. It was just making up a migration on its own. And it had no basis in reality. And the code did not compile. So anyway, let's see if there's a result here. I'm gonna wrap this up when this finishes. Yeah.
Use any instructions, your agents that you are referring to? You provide any instructions to your agents that you are referring to?
Instructions. Yeah, I do have I don't want to.
You do that wrong.
Yeah.
You're telling it exactly.
Yeah.
where to go.
Yeah. We've been yeah, most of our repos at work now have instructions files, and one of the instructions is like make sure everything compiles. And make sure all the unit tests pass. And then usually the tool will figure out if it's made a horrible mistake. Anyway, so I think our task, our Copilot task finished, and now I'll click on what has changed, and you can see that the agent figured out pretty much the right thing here. Changed the source file, and then it changed the POM XML, and did a pretty good job here. It just took a little longer. This might be the future, but I don't know, like if I'm patient enough to wait for this to happen again. Kind of like just running a well-defined recipe. The thing about the using an open rewrite recipe is that it's deterministic. It'll always get you to the same output. I don't know if Copilot is how deterministic this agent would be. It may, like, I may run this tomorrow and get a slightly different result. So it might not be like,
Depends on how detailed your prompts are. That's one thing we
Yeah.
haven't had it in previously company-wide. You have a curated prompt that's like a mile.
Yes.
Make sure it doesn't go off the.
As long as it waits for a human being to emerge the PR.
yeah. So admittedly, this prompt that I used here to delegate this task, this is not a very precise thing. And in a real world scenario, yeah, like the more context you can provide to the agent, the better the agent's going to do. I just got lucky that this worked. Maybe. Anyway, final thoughts. Hopefully, continuous integration and continuous delivery are kind of like core principles. You want to be able to rebuild your code frequently. Hopefully, you're releasing code frequently. And then figure out who owns the code. We've had this problem at work where there's some libraries that had no owner because like people left the company and then nobody wanted to touch certain repos. And now like I own all those repos. Well, not intentionally, but sort of unintentionally, like somebody has to go deprecate old code.
You touched it, so you own it.
Yeah, I did touch.
You made that one comment back 2 years ago, so it's yours now.
Yeah, that happened to me a year ago. I touched some repo that had some Scala code, and then nobody has touched it in the last year, and now people are like pinging me for support on it. And I was like, I don't own that. And they're like, but your name's there. So yeah, ownership's a problem, especially for internal libraries. Sometimes internal libraries, nobody wants to keep them alive. And then Open Rewrite is great for complicated migrations. And what's nice is you can also build your own internal recipes. That's what we're doing at Grubhub. So we take the open source recipes that everybody has. Those are just building blocks. And then we write our own recipe lists. And then we have those internal recipes are what we execute because we want to apply a bunch of changes all in sequence. So it's great for composing bigger recipes out of small recipes. Anyway, that's sort of the end. I don't know how we are on time, but I'll take like 2 questions.